This is the latest member of the family for our signal controllers. This is a Dwarf signal controller for LEDs. So we invented the signal controller which had fiber optic outputs, and that was necessary because the N scale and HO Dwarf signals are so small, and that's what we've been selling for the last 3 or 4 years. But more recently we've increased the number of customers asking us for G-scale. This is actually a G-scale Dwarf signal with the LEDs in it, and that's just the way it comes like that. And so we're going to run this signal controller off of, the Dwarf signal controller. We're going to run the Dwarf signal. And the first thing we're going to do is run it off of just regular DC power. So if you have mechanical switches, tortoise switches, N-scale HO, you have wired LED Dwarf signals that you want to use, this is the product to use. And it's pretty simple. Power on or plugged in, and then we turn the power on, and you can see that it blinks a couple of times. That tells us that it's up and running, and we have the green light set. So on all the signal controllers on the left-hand side is a terminal block with 3 terminals. The top one is a common. The middle one is latching. We're not going to get into latching today, but all of our signal controllers can latch forward and latch back between blocks. And then the bottom terminal is for connecting up your detect signal. Typically that'll be a precision detector, but you can run it off a tortoise or other kind of slow motion machine. I think you can see the green light there. I'm going to connect this short wire. It's just a bare metal here. I'm going to just touch it to the ground and then connect it to the detect line. Straighten that out a little bit. And as you can see, when it's on, the light, whoops, I'm a little slipping there. The light turns red, and when I release it, the light turns green. Okay, so that's just the way it works. You saw it fading from red to green and back. So let's just do it one more time here. There we go. On and close. So now which one is for the main line and which for the throne for the siding is completely up to you. You can reverse the wires to make that happen. Each of our signal controllers has a set of 2 outputs, so you can run in G-scale you can run 2 Dwarf signals. In N-scale and HO, in the smaller scale where the LED has a lower voltage, you can run 2 off of each pair of terminals. So you can have 4 Dwarf signals. Now all our Dwarf signals have interlocking, which allows you to have a cascading ladder in a siding or a set of sidings. And so there's a lot of function here, but you don't have to go through all of this to get the basic function working. Just plug it in and it'll go. You can adjust the brightness of all the 4 outputs, and you can switch between fade mode, turning it on and off. And so we've been watching fade mode. So if I press this 6 times, 1, 2, 3, 4, 5, 6, that will turn the fade mode off, and that will just cause the lights to be changed instantaneously. Okay, so you see that. All right, so that's the setup with basic DC 12 volts in. We're using our power module, which is a 12-volt supply, and this is an AC adapter connected to a wall circuit. All right, so let's switch over and let's show you how to set it up for using with DCC. Okay, now we're going to show you the setup with DCC. In particular, the customer that we were working with has a DCC setup. They actually have a Pico system, and they have all their turnouts are DCC, which is really nice. But to add the double pole, double throw adapter onto the turnout machine to flip this in the mechanical 12-volt mode is, I don't know, somewhere near $80. So it's very expensive. And so one of the ways you can run your Dwarfs in parallel with any turnout that's DCC is to use the same Dwarf signal controller. So I just have my Digitrack system here, and I'm just going to add power to the track, and it's going to boot up identically to the way it does in 12 volts. Now, out of the box, the address for the signal controller is 1. And so it's an accessory. And so you'll make the address, the primary address for this, the same as your turnout. So if your turnout is 5, then you want to make the signal controller, Dwarf signal controller, 5 as well, so they'll work in parallel. And there's no problem with that. The DCC signal can run, power many devices simultaneously, and that's the way you do it. All right, so we have this set to 1. I have my controller here. I turned the switch, and so I'm just going to, and it's set to address 1. So I'm just going to press the thrown and close button, and you can see that the light changes. I'm going to change this back to the fade mode. 1, 2, 3, 4, 5, because I just think that looks cool. All right, so there you go, the switching of the Dwarf signal back and forth. To change the address, hook up to the main line like we have here, press and hold the select button on the signal controller. The lights will go out, and after a couple of seconds, the lights will come back on. You let go of the button, and when it starts blinking like this, it's in address setting mode. And so you can take your signal controller and pick an address. Let's just pick address 5. So we're going to pick switch 5. And even though the switch on your turnout might change, it's not going to change your turnout switch. But this controller is going to remember that address. And all you do is press either thrown or closed, doesn't matter, and you'll see that the lights will blink. And now address 5 is thrown, and so it's red, and we can press closed and it will switch back and forth. So now this signal controller is set to address 5, and it will parallel the switch. And you can set it to any address in the switch category, so that's from up to 2043, and you could do 2044, which is the last switch address. However, if you want to use both DCC addresses in the controller, you have to come one down. So this would be 2043, and then that would automatically make this 2044. That's kind of perverse, but you can do it. And the last thing is on the bottom of the larger scale, so this includes O scale, so G scale and O scale, there are magnets. And if you use a flathead screw and put it into your layout or wherever you're going to mount this, the flathead screw will stick to the magnet. You can put 2 of them in so you prevent it from torquing. Now you can't use stainless steel because stainless steel doesn't have any iron in it. It has a little bit of iron, but not enough, and it has other alloys that prevent it from being magnetized. So you'll have to use something like zinc, which also has zinc coated, which also has the iron alloy, or you can just paint over it if you're concerned about outside elements. Anyway, that's all there is to setting up the signal controller for DCC operations.